Hello everyone, thank you for stopping by. Today we're going to go over some of the important aspects of exponents and roots. And because there is no better way than the easier way, let's look at some of the laws or rules of the exponents. If we have to multiply this couple of bases here, and this one has the exponent x and this one has the exponent y, the result is going to be b to the x plus y. So we add the exponents. Conversely, if let's say we have b to the power of x over b to the power of y, of course, I think you are thinking about that too. So b is going to be, the result is going to be the base, in this case b. And now instead of adding like we did when we were multiplying, now we're going to subtract. So we're going to subtract the exponent on top and minus the exponent on the bottom. Now, the last law that we're going to talk about today is going to be when you have this in a parenthesis. Let's say you have b to the x power inside of a parenthesis elevated to the y power, or the power of y. So what we have in here is now we are going to multiply these two guys. So now the result is going to be the base b elevated to the power of xy. So when we multiply, we add the exponents. When we divide, we subtract the exponents. And if we have a parenthesis elevating a quantity inside, well, we multiply the two exponents on both sides of the parenthesis. So x times y. Well, now let's talk about roots. Well, you know that roots are the opposite of the power, right? So if we have, for instance, let's say 6 to the power of 2, or 6 to the second power, this is going to be equals to 6 times 6, which is equals to 36. Now, the square root of 36, we can understand this as, okay, we are going to look for a number that when you times it by itself twice, you get 36. In that case, the answer is going to be 6, right? Because 6 times 6 gives you 36. And this is a square root because when we don't see a number here, we assume it's 2. So we know it's a square root. But there are all sort of roots out there. Cubic root, the fourth root, the fifth root, and so on. But we're going to just focus on this square root. So now let's look at something interesting here before we move forward. I'm going to connect these two concepts, a little bit of exponents with roots. So look at this. This is like another law that you have to consider. If you have x to the to a negative power, elevated to a negative power, this is going to be equals to the reciprocal or the inverse. So you have 1 over x, and now the exponent will become positive. Okay? Just think of this as another law that you need to understand. For instance, let's say that you have 5 to the negative 2. This is going to be equals to 1 over 5 to the second power. We changed the negative 2 and we kept it positive. And if we solve the denominator, we have that this is going to be equals to 1 over 5 to the second power is 25. Okay? So if we have 5 to the negative 2 is the same as having 1 over 25. Simple. We have a lot that if you have a quantity elevated to the 1/2, this is the same as having a square root of 25. See, the 2 belongs to the root and the 1 belongs to the exponent of the number you are operating with. Okay, so let's say that now you have, instead of 25, to the 1/2, you have 25 to the 2/3, okay? So we apply the same principle. The denominator will go to the root, so it's gonna be the cubic root of, in this case, 25 to the 2nd power. This 2 stays with the base. So this is just an identity that I want you to become familiar with. So let's stick with this one. This is simple. So 25 elevated to the 1/2 is the same as square root of 25, which is equals to 5, right? Square root of 25 is 5. 5 times 5 equals 25. Now, let's complicate things a little bit more. Now imagine that you have 25 elevated to the negative 1/2. I am combining those two laws right now. So you know that if we have a negative power, that means that to solve it, we need to do the reciprocal, right? We do the inverse in here. So we have 1 over 25, and the exponent becomes positive. So now it is elevated to the 1/2, right? And now, when we have 1/2 as an exponent, is the same as a square root. So now we change that to the square root expression, right? And this means that we have, if we have 1 over the square root of 25 is the same as having 1 over 5. You got it, because the square root of 25 is 5. Now, let's go to the beginning. If we have to find the result of 25 to the negative 1/2, what's that? That is 1 over 5. I know it looks crazy, but if we combine both rules, that's where we arrive to. Again, we start by taking care of the negative part of the exponent, making it reciprocal. So we do 1 over the base, and then we just make the exponent positive. And after that, since we know that elevating something to the 1/2 means a square root, we do just that, 25. We put it inside of a square root, and of course, that gives us 5, okay? Simple.